So it's not completely surprising that Hitler could solve a problem that the previous government, the Weimar Republic, could not solve. And Japan has its own boom at this point. As I said, it has become westernized. Those are French officers visiting the... That's actually admiral. Now that's important. So Japan is having its own economic boom, but it's kind of weird. It has an emperor who's worshipped as a god by ordinary people. But the political power increasingly, the real power increasingly goes to the army. And in fact, it's the army that invades China and then tells the emperor, we invaded China, is it okay? And the emperor basically has a choice. Withdraw, which is humiliating, or just take credit for it. So Japan is creating a very weird political system. But eventually that military dictatorship. So Japan has become actually constitutional monarchy in a sense, because they have a parliament, they have elections, but the power increasingly goes, the economic power increasingly goes to the military. And the military invade a great empire. You know, they started with invading a piece of China, then the full score. This is the first major massacre carried out by the Japanese in Asia. Between Japan and Hitler's Germany, I don't know which one was worse in terms of the atrocities they committed. We read more about the German doctors performing experiments on Jews and so on, but Japan did incredible things in China. Just anyway, so eventually Japan, Germany, and Italy find themselves allied. China has become much more interesting now. In the old days, very few people cared about the history of China. China has been declining dramatically. It's become, from being at the most advanced civilization, it has become a joke. And foreign powers do what they do there, do what they want there. And Japan does what it wants in China. They don't even need to invade the whole country. They just control they have power over the government. And so what happens is that these gentlemen, and then of course Sun Yat-sen and Mao Zedong, they start a new way of thinking and they want to overthrow the emperor. Now what is interesting that all these gentlemen were trained, educated abroad. And typically Japan, this is weird, Japan has become the role model for the young Chinese. Historically, this was unthinkable. I mean, Japan is the one that took the Chinese characters. Japan is the one that took Chinese Buddhism. You know, not China. China didn't take anything for anybody except for Buddhism. And so this is when Confucianism falls in disgrace. And that's when Marx, these people are fascinated by Marx. Marx is European. Finally, China found something that they like about Europe. I mean, it's the first time that China looks to Europe as a role model and to Japan as a role model. And so Mao Zedong is Zedong is the first name. In China, it's always so Mao is the one that strongly communist, and eventually wins a civil war against the nationalists. Sun Yat-sen is really the one who started the revolution against the emperor, deposed the emperor, but his republic, that was Western-style democracy, lasted just a few months. And then there was a long civil war, a brutal civil war between this guy and this guy. This guy is the one who eventually went to Taiwan. That's why Taiwan is the separate country. Eventually the loser fled to Taiwan and started a separate government in Taiwan. Anyway, what these people have in common, westernized. They're westernized or influenced by Japan. You know, educated in Japan, married to a USA educated woman. And Mao is a Marxist. He reads Marx and Lenin. So that's China will fall under Mao. Mao will win the civil war, and China will become even poorer. Sometimes it happens. You know, the outcome of a revolution is not always better than what was there before. And China will remain isolated for 40 years, more than 40 years. In the Arab world, all those countries become independent. Some of them were the remnants of the Ottoman Empire, inherited by Britain and France. Eventually, Britain and France gave them independence. It's kind of interesting that these countries were colonies of European powers, which today would be unthinkable, right? Islamic countries ruled by Christian countries. But for a while it was okay, it was not a big deal. Anyway, they all get independence eventually. Latin America, they've already become independent. There's been a few wars here. So this is under Spain, you know, New Spain, today is Mexico, New Granadas, which today is Colombia, Venezuela, and so on. And then down here, eventually, Peru, Argentina, and so on. So eventually they get independence, and that's today's Latin America. What is happening in Latin America is dictators. You know, Vargas, Cardenas, Perón, and then Castro, and then many others in pretty much every country of Latin America becomes ruled by these, I call them populist rulers that promise to look after the people. These are not good days. We're not living in good times. Before World War I and between World War I and until the 60s, you have a lot of millions of people dying of starvation, disease, and so on, one after the other. And the United States also has its own Great Depression. It doesn't kill millions of people, but I'm sure it did something. Today we live in a very rich world. That's the message, you know, by comparison.
It's just amazing though that there was such a switch from this 1880s to 1920s phase of like...
Yeah, going up and up and up and up.
And then...
And then, yeah.
But like worldwide too.
History is funny, huh? Yep. Good news, these are the times when you start having women's liberation, at least in the West. The most gender equal country is actually Russia. The constitutional Russia, in theory, granted women exactly the same rights. Of course, they didn't have any women in the higher levels of the party, but. And who started the Russian Revolution? Most people don't know, but it started on, Women's Day. It was Women's Day, whatever, in Russia. And the women were actually the leaders of the revolution. The first ones to riot, demonstrate in the streets, then joined by the students, by the workers, and so on. I think it was the same French Revolution, by the way. I think the first people to start the trouble were women. And you have suffrage in many countries. I'm always amazed that people think the United States became a democracy in 1776. Until I think, I had a discussion not long ago with a friend who was saying it's amazing that people with black skin did not have the right to vote until 1860 something. I told him, what about the fact that women, which are 50% of the population, did not have the right to vote until 1920? It seems even more shocking to me. You know? Okay, now science is beginning to become relevant. It's not just speculation. That's what I wanted to say when you asked the question about science. And chemistry is the one place where you see it. You know, polystyrene, polyethylene, I didn't even know how to pronounce it. Here, today's products. Back then, of course, it wasn't that way. But all of these things, nylon was nylon. So this thing will definitely change the domestic sphere. I mean, besides cars, airplanes, that's why I said everything that is in this room comes from here. Okay? And a lot of the pollution in the world and in the oceans come from here. So that's one case in which is science. You know, chemistry has been. That's why I think Lavoisier is underestimated. He should be up there with Darwin and Newton, whatever, because he's the one who told us fire air, water are not elementary units, that they are not the fundamental constituents. You know, the Greeks, it goes back to the Greeks, it goes back to so many civilizations, and he explained not. It's fire is just a rapid oxidation, and water is hydrogen plus oxygen, and so on and so on. That was the beginning. That was just science. But then, using that science, okay, we invented new materials, and those materials go on to change society. This is marginally influenced by science because it comes from electricity, and at that point, people like Hertz have made major progress in understanding how electromagnetic waves propagate. And then we start having the first, shall we call it consumer electronics? This was the first TV invented in San Francisco. And the office is changing, same reason, electricity. The house is changing. These are some of the earliest appliances. And the car is changing the landscape. The airplane will very soon change the landscape. By the way, the 1939 Pan American has the first transatlantic passenger service. That was for rich people, right? I don't know if you can see, but it was physically like apartments. It was much more comfortable than it is today. That's inside the plane.
Mm-hmm.
Right? So it was actually more. I mean, today we are the opposite.
Crazy.
Today we are treated like animals on those planes. Okay, I want to do this guy. So definitely the revolution in communication is still going on. Now, in terms of philosophy, last time we really saw the big philosophical, boom that started with the Renaissance and went all the way to the idealists, to Kant, Hegel, Schopenhauer, and in Scandinavia, Kierkegaard. And so philosophy in the 20th century, when it's so recent, it's hard to focus on what is future generations will remember. And of course, because now science is decoupled from philosophy, philosophy becomes less relevant. You don't go and read a philosopher to figure out why we have stars in the sky. You buy a telescope and you take a class of physics. So it's no wonder that at the peak of the industrial scientific revolution, you have the German philosophers. Germany is one of the most industrialized and scientific countries in Europe, and the German philosophers are the ones who distance themselves from science and technology and start looking inwards increasingly, and that they almost had a negative view of what is going on. This will accelerate in the 20th century. So to me, philosophy becomes almost a counterpart to science and technology. Science and technology tells you how to build better chairs, better cars, eventually better devices. Philosophy sort of tells you, yes, but what about you? You. Focus on you, your life. Okay, so it becomes a more intimate kind of philosophy. So Wittgenstein is, in my opinion, one of the most influential philosophers of that time. And he and others, I thought it was here, focused also on language. But language is something that science doesn't explain, but it's something we do every day. And it has something to do with the way we think. And he realized that language cannot be defined mathematically. And a word really depends on the context. And if I say rose, you don't know anything about the meaning of what I'm saying. Is it rose is my friend, or I bought a rose? Yeah, so you need a context to understand something. And that's not enough, actually, because the fact that you rely, the moment I say I bought a rose, you might think, haha, it's girlfriend's birthday. So the meaning really depends on the huge context of language. In a sense, every word's meaning depends on the meaning of all the other words in the language. So we started this conversation. In psychology, in psychology at this point, there's two schools that fight each other. We still know very little about the brain. That's coming, but right now we still know very little about the brain. And one school is the behaviorists. They just want to look at your behavior. And they think every effect has a cause. Every stimulus has a response. And so if I condition you, you will have a desired response to a stimulus. Pavlov's dog, have you read of Pavlov's dog? You make the dog salivate just by ringing a bell or something like that. So there was one school. And there was sort of a, I don't know what to call it, digital school, one-to-one. You know, there's a stimulus, there's a response, okay? And there's a way to control that thing. The alternative, the opposite school, which was mainly in Germany, was Gestalt. Gestalt means shape, form. And the idea was it takes more. You can't isolate the single stimulus and the single response. What we see, when I look there, I don't see a series of dots. I see a clock. I see the whole thing. The whole is more than the sum of the parts. So they thought you cannot break down human perception in atomic ways. The opposite, you know. Human perception is a whole. Their strong asset was optical illusions. Why do we have optical illusions? The behaviorists had trouble explaining optical illusions. They had no trouble. They said, well, we try to understand the shape, the whole thing. And sometimes to do that, we make mistakes. How do we solve problems? According to Kohler, problem solving is not breaking down the problem, it's a problem, it's a problem, it's a problem. You're just focusing on the problem, and suddenly you go, aha. What has happened, your brain has, I'm using today's words, your brain has reorganized, and suddenly the brain sees the solution. So two different ways to look at the world. And yeah, so they came up with things like this. And actually, it was the Gestalt school thought in the brain functions are not localized. There is no specific place where something is happening. It takes the whole brain to recognize an object. It takes the whole brain to speak. It takes the whole brain to see that clock. Yeah, so, and he was also aware that the brain is fault tolerant, meaning if parts of the brain of your brain get damaged, very often you still work perfectly well. In fact, now we know that neurons die all the time, but we don't get senile right away. You know, the brain is capable of working even without some of the neurons working. So he already had that intuition that it's the whole brain that works. Of course, he had no idea about neurons and synapses and so on. Gestalt is one of my heroes, very underrated. He thought, so at this point psychology is becoming more serious about trying to understand how we think. Okay? Now if you, how do we do normal things? Normal things are actually extremely difficult to do. You walk into a restaurant and you wait for a waiter to seat you, and then you read the menu, and then you order. How do you know all these things? I mean, if you had to physically compute what's in that situation, there's an infinite number of things there. There's people with umbrellas, well in California no. There's people with books, there's people with smartphones, there's people coming out, going in, but we understand right away this is a restaurant, we have to wait to be seated, then somebody will give us a menu, we order from the menu, we wait, food will come. How do we know that? Well, he said that's because our brain works that way. We have schemas. A schema is basically a stereotype situation. We know that if we are in this situation, these things will happen. If you are waiting for the bus, you know the bus will stop, then I walk in, somehow I have to buy a ticket, and I have to sit, and then I have to know where to get off. So our brain is organized in these schemas that tell us how to do things. So we don't have to do a massive amount of computation to figure out what do I do now. Okay? Once we are in this situation, we know what to do. That was a powerful intuition, actually. Otherwise, the computational complexity of moving a step would be too much. Well, Piaget, you probably heard of it, he thought the mind is not always the same. The mind grows just like the body. So the child's mind goes through 4 stages, 5 stages, and at each stage we're capable of more mental operations, all the way to the abstract level. Sapir also studied language, like Wittgenstein, and he and another gentleman, Worf, introduced the theory, but it's more than a theory. I think there's consensus that we're right, although they used the wrong evidence, that language has an influence on your mind, or the way you think. The way you think influences language because you say what you're thinking, but it's also true the other way around, that the language that is spoken to you has an influence on your thinking, on your psychology. These are all very important. I'll mention, well, the last one probably is obvious, short-term memory, long-term memory. Today we know that's even more. But the first one is important. It's another psychologist who tried to understand how do we do things. Today, I would put it this way. You go see a movie. Then I ask you, so what's the movie about? And you tell me what the movie is about, right? How do you do that? I understand the computer who would just show me back the movie frame by frame. The movie would memorize the entire thing and show it again. But you are not showing me the movie frame by frame. You are summarizing it. You are summarizing it. You are using words that are different. If you try to quote one of the actors, or at some point the actor says, you are not going to use the exact same words. You're using your own words. How do you do that? And if I ask you, 5 minutes later, I ask you, tell me again what the movie is about, you will not be able to use the same words. You will tell me again what happens in the movie, but you will be using different words. So he realized that we do something funny. When we say we remember, it doesn't mean we store. See, a computer stores. A computer knows the exact words that were said in that scene of the movie. You don't remember the exact words. You just remember that he's in love with her and he said something that upset her. But that's not in the movie. Physically, the words you are saying are not in the movie. So he realized that what we do is reconstruct. Our memory is reconstructive. And that was a powerful intuition. Because think of it, if we had to store this scene, if you had to store my words right now, the sounds are coming out of my mouth, pixel by pixel, or phoneme by phoneme, it would take an infinite amount of memory. The brain just can't do that. Not only that, it would take an infinite amount of time to act. If you have to use all this information, then deciding what to do becomes very problematic. But the memory, the human memory, is amazing. It takes whatever is happening in the world, summarizes it in a way that can be used. And that's why when I asked you to tell me about the movie, in your brain you don't have the movie. You just have the summary. That's the idea that memory is reconstructive. Right? So these psychologists were coming up with very powerful ideas that we know they are true, except they didn't know how to express them in terms of neurons. Now, relativity had an impact, and quantum mechanics had an impact on physics, on the way we see the world, and that changed the way we think about the universe. It was already powerful when we discovered the first nova, a new star in the sky, when when Copernicus told us the Earth is not at the center of the universe. But then we find out that our galaxy, the Milky Way, has what, 100 billion stars? You know, and that's just one of the 100 billion galaxies that we've seen so far. So this becomes really huge. And Hubble discovers, and Schwarzschild finds out that in Einstein's equations, there's one special case, which now we call the black hole, which is a star a body so small and so dense that the warping of space-time is not like this, it's like this. It means you will never go from here to here. If you get here near the black hole, you go like this. You will never get to the other side. You fall forever into the black hole. Yeah. And Hubble discovers that the galaxies are moving away from each other. All the galaxies are moving away from all of the galaxies. That's the expansion universe. And today we know that actually that thing is accelerating. So we start having this image of the universe that starts from some initial point and then it starts expanding and expanding and expanding. So the theory of the Big Bang is born. This completely changed the way we see ourselves in the universe. You know, the Earth is not special, and the Sun is not special. Milky Way is not special. That's a major humbling experience, you know, that comes from physics. Very few people understand why, you know, the equations, you know, very few people understand the equation, but they understand that we are not that special in the universe. Now, quantum mechanics was the weirdest of all these things, in a sense, because, okay, Einstein tells us that space-time is not like this, it's warped by the masses. Okay, fine. But quantum mechanics gets even more extreme, because, so first of all, do I have the list now? Yes. So first of all, how do we know quantum mechanics is right? Well, these were just very simple experiments, just simple explanations. Planck realized that there's a case in which he could not make energy vary continuously. It was like this, steps. So there's energy quanta, not it's not continuous. And then Einstein explained that the photoelectric phenomenon by the same thing. Light is photons. And then the atom, they realized that the atom has electrons around the nucleus, but the funny thing that the electrons are only here, 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 and here. If you try to move them in between, they jump here, or they stay here. You can't have an electron in between two orbits. So this keeps happening in nature. As we study nature, we realize that nature actually is discrete. You know, there's something where you can't go any lower. That's true also of space. You know, space is a grid. The vacuum, the quantum vacuum is inside the grid. There's nothing there. Physics does not apply in there. Okay, so just the way nature works. But this thing has consequences. And the consequences, I will not give you all the thing because it will take forever. But one thing that comes out of this, let's start with this. Heisenberg realizes that you just do the formulas and you realize you cannot know the position and the velocity of a particle at the same time. You choose one or the other. The more you know one, the less you know the other one. So there's some uncertainty built in the system. This gets a little exaggerated. It's not true that we cannot know anything. If you want, you can know exactly where the electron is. You will not know the speed. And you can know the position and the energy, but you cannot know the energy and time. You know, so there's things that you cannot know at the same time. So there's a level of, the correct term is indeterminacy, but people say uncertainty. And that's not because of our ignorance, it's just because the way nature works. The vacuum is not empty. You can never have a place with absolutely no fluctuations. And that's why you probably heard of the energy of the vacuum. It's mind-boggling. There's nothing there, absolutely nothing, but there is some energy. Antimatter, which today we take it for granted. Electron, positron, every particle has its antiparticle. Well, but that, when it came out, it was not so obvious. I mean, that there's this antimatter, you know. For every particle in my body, there's an antiparticle somewhere in the universe. And if we ever meet, bad things happen. Non-locality, which Einstein did not believe. You have two particles, they are entangled. Okay? When you have two particles interactive, they are entangled. You have an equation that says how they interact. Now you take them and push them very, 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 very far as possible. They're still entangled. You touch this one, the other one reacts. Okay? Einstein thought this was not possible. That has been verified repeatedly. And the biggest one is here. Schrödinger figured out the equation, the equivalent of Newton's equation, that tells you how a system evolves in time. You tell me the system now, Schrödinger will tell you the system 3 hours from now. Okay, it tells you if it's this system in this kind of situation. All right, the equation tell you what's going to be like in 3 hours. Except his system is a wave. They realized that system describes a wave, but I'm actually studying an electron. Now, somebody else had come up with the idea that particles and waves and particles are the same thing. They're just different ways to describe things. Okay, so Schrödinger's equation describes the electron or some other particle as a wave. But what does that mean? And eventually they got it. It's a wave of probability. It tells you the probabilities that the electron is in this state, 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 in this state. So Schrödinger correctly predicts the probability that the electron will be this, or this. When you observe the electron, if you observe it 100 times, you get exactly this probability. It's not always in the same place. 20% will be here, 15% will be here, 35% will be there, and it's exactly what Schrödinger predicted. But what the heck does it mean? You know, with Newton, something is here, 3 hours later, Newton tells you it's here with this speed, this acceleration, this energy. Schrödinger just gives you probabilities. Probability, 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 probability. Then here, you look in the microscope, and bang, you find it here, and it is one of the possible solutions of Schrödinger's equation. But basically, you have to look. When you look, you cause this wave to collapse into one number. That's really puzzling. If you don't look, then there's still a wave of probabilities. When you look, bang, the electron here. Then it restarts as a wave. Sounds weird, right? That's what happens every day in laboratories around the world. Okay? It's only when you look that nature decides where the electron is. It's almost like nature is lazy, lying on the beach, and when somebody actually looks at it, oh, okay, here, it's here. Okay? Very weird. And so, of course, a lot of philosophers discussing this, and one of the greatest scientists, von Neumann, tried to figure out what does it mean? Is it the microscope, the equipment that causes the collapse? Is it my consciousness? You know, it takes a conscious being. When a conscious being looks, then nature decides where the electron is. They're still discussing. Yeah, so if you put them together, relativity, quantum physics, and thermodynamics, they pose limitations. The speed, you cannot go faster than the speed of light. The amount, you have quanta, and the quality, uncertainty of information. These are all things that we took for granted for thousands of years. There's no limit to speed. There's no limit to how small energy can be. And you can always know precisely what is going on. You put these three things together, it's not. Anyway, in thermodynamics, I forgot to mention entropy. That's the other big thing, right? It's the first equation of physics that is not an equal sign. Entropy can never decrease, greater or equal. So this will not have an immediate impact on technology, but they definitely contributed to to change the way we look at ourselves. I mean, now we know that this is just a bunch of particles driven by some weird waves of probabilities. And we still don't know what matter is made of. We still have doubts about what's there. At the end of the day, what's in there. So in between, at the same time, there was a lot of discussion on logic. Okay, because logic was the foundation of science. The whole idea of science is that you have to prove something. You know, you do the experiments and whatever, then you come up with some theory that has to be proven, and it can't be disproven. Russell, I mentioned Russell was one of my favorites, but several people realized that logic is a problem. Take this statement, I am lying. Is this true or false? If you are lying, then you're telling the truth. If you're telling the truth, then you're lying. And more complicated ones I want to do, but you can do it at home. The barber who shaves all barbers who do not shave themselves. Sounds like this is somebody who could exist. Do it at home. Try to focus on the barber who shaves all barbers who do not shave themselves, and you will see that that person cannot possibly exist. So anyway, they realized the problem with logic. Hilbert came up with, Hilbert was one of the most important mathematicians of the time. He's the one who rewrote Einstein's equations. Einstein's original equations were not easy to understand. Hilbert wrote them the way we use them today. And at one point, Hilbert came up with problems. He told the mathematicians of the world, logic has advanced so much that we should be able to do A, B, C, D, and so on. One of the problems, I don't remember the German name, one of the problems was, can you find, if logic is so great, you know, we have these tools of logic that help us prove theorems. Can we come up with a procedure that we give to an ordinary person, and that ordinary person, just by using that procedure, will prove any possible theorem? If logic is so powerful, I'm using today's terms, not his terms, but that's at the end of the day. Is there a procedure that I can give to anybody, and you just use the procedure and you solve any problem? So that had two consequences. One was bad. Kurt Gödel proved that there is always at least one statement that you cannot prove true or false. It's not that it is false. You cannot prove whether it is true or false, always. Any logical system that includes arithmetic, okay? So any logical system that we use in practice always contains at least one statement that will defy the greatest mathematician in the world. Period. That's proven. The second, so that's another thing that changed the way we think about ourselves. So nature has designed us in a way, designed the entire universe, whatever, our way of thinking, in a way that we can never know everything. The second consequence was actually positive, because eventually somebody came up with that procedure. Footnote, Gödel says that there's one thing that you cannot prove, okay, but that's just one. But somebody came up with the procedure that Hilbert was looking for, and that was Alan Turing. Alan Turing came up with the Turing machine, which was just a thought experiment. He never built the actual machine. And the Turing machine does exactly what Hilbert was asking. It's a set of instructions that you follow, and with those instructions, you can solve any possible problem. And today, that's called computer. So that was the foundation of the computer. He had invented the computer without actually building one. But every computer today, including my smartphone, is a Turing machine. So one of the indirect consequences of Hilbert posing that, let's see here, Unterscheidungsproblem. Problem. That's the problem that led to the Turing machine, which led to today's computer. So that's why I'm mentioning that there was also progress in logic. It was not just philosophy. Eventually, it led us to understand how we can build a machine that solves all possible problems. See, what's the difference between the computer, the washing machine, the refrigerator, and so on? All of these machines were amazing, the car, the airplane, but they can do only one thing. The computer can do everything. You just connect it to something and can do anything. That's the big difference. And that's precisely what Hilbert was asking for. Can you give me a procedure that will solve every possible problem? Well, that procedure, actually, once you implemented it in hardware, is the computer, which is the first appliance that can do anything. Can drive cars, pilot airplanes, control your thermostat, make phone calls. Biology is just the beginning. I want to do that. Philosophy. Now again, philosophy at this point almost sounds like a reaction to everything that I tell you in the science and the mathematics. Heidegger is saying something that Kierkegaard already said, you cannot separate. Science is false in a sense, because science separates the subject and the object. Science says, I'm observing the world. And Heidegger says, you are part of the world. How can you observe the world? You are part of the world. You are in the world. So he believed that the ultimate way to know truth is, you could call it the instinctive way. We just act in the world. We don't stop and do what a mathematician would do. Okay, this is the situation, let me write it as a theorem with formulas. Let's solve and decide what do I do now. No, we just walk into the restaurant, wait for the waiter, sit, and so on. We are thrown in the world. Okay, so you see, again, philosophy. Is it the next slide? No. Philosophy is going the opposite direction. It's almost saying, okay, science, technology are giving you skyscrapers and airplanes, but don't forget that real life is different. Okay? Real life is a different kind of thing. So technology alienates humans because it separates us from our natural environment. It creates an artificial human being that doesn't live in the environment. We live in an environment. We are surrounded by other people. Okay? Don't want to do this. This one is kind of interesting. This philosophy is kind of interesting because today we talk a lot about biosphere and noosphere. He saw that all this knowledge that we are acquiring, he saw it like a collective improvement in consciousness. It's another stage in evolution where we evolved from the biosphere and we entered the noosphere, the sphere of knowledge and so on. So today with the internet and World Wide Web, this story is even more plausible. And if you heard of the omega point, he came up with the idea that there's an omega point at the very end. He was a religious person, so he was reconciling science and religion this way. Now, all this philosophy eventually converges in France on existentialism that becomes at one point the most powerful school of thought in philosophy. And again, it almost feels like it's a reaction to science and technology that is progressing so much, that are creating this technocratic society. And existentialism is almost like a loss of values. Why am I alive? What am I doing here? What's life supposed to be? How am I going to live my life? And Kierkegaard was the one who invented this discussion. Okay, you give me all this technology and science and whatever, but you don't explain my life. What am I doing in this world? So the existentialists, mainly Camus and Sartre, came up with non-answers, basically. Life feels like it's useless, especially at this point where they don't believe in God. Religion is powerless at this point in the world of science. But so then what is that I'm living for? And Camus didn't find the solution. And Sartre eventually became, they were both left-leaning. Sartre became a Marxist. And Sartre also, so existentialism does not have a solution. It's a very pessimistic philosophy. But it sort of emphasizes that we don't have the solution. That's precisely the point. We don't have a solution. All these technology and science are not the solution. Sartre in particular said the curse, the real curse we have, is that actually we have choice. If we didn't have choice, think of an animal that's just looking for food, looking for sex, and then dies. All right. But we have choice. That's terrible, because now we should use that choice, but what do we choose? How do we choose it? So choice becomes actually a curse. You know, it's a dramatic part of the human being. Okay, I don't want to summarize existentialism more than this because I know I'm not doing a good job to them. The point is, while science and technology is creating our modern society, the philosophers are looking at us, at the person, at the human being. Fine, you can build as many skyscrapers as you want, as many railways as you want, as many smartphones as you want. But how do I live my life? Why am I here? What do I do now? Okay? So anxiety, this is the age of anxiety. You know? We are alone with no excuses. That's one of my favorite quotes from Sartre. Anyway, okay, so it's the fact that there were these two world wars might also explain why philosophy is so bleak here. I mean, with all the, what do we do with all the technology we are inventing? We kill ourselves. We kill each other. So World War II involved 61 countries, 3/4 of the world's population. Number of people in the military, incredible, 110 million. Half of those people died, 55 million people dead. And yeah, so I'm sure you know all the level of atrocity is unspeakable. And today, when I hear about ISIS, compared to this, ISIS are still amateur. Nothing compares to this. I don't know if I have pictures. Even, I mean, this is big devastation, Nagasaki, Hiroshima. But you have pictures of like the Ustasha in Croatia sewing the head of the Serbs because they hated each other. It's just what happened in World War II is unbelievable. In a sense, in my opinion, the Hiroshima and Nagasaki were almost humane by comparison because they ended the war. It was just a war of brutality. And I don't want to get into all the politics. Of course, Germany, Italy, and Japan had their own version of history. I mean, Germany and Italy just wanted the colonies that the West had. And Japan was liberating Asia. I said Japan won the war against Russia. That was a big thing. Well, created the psychology that Japan was the Asian power that could stand up against the Europeans. So then the Japanese justified themselves as we are liberating Asia from Europe. Never mind that they killed the millions of Chinese and Indonesians and so on. Out of World War, good things came out of World War II. One is the computer. So Alan Turing was one of the consultants, by the way, for the first computer. And computer is invented, and in '46 you have the first commercial version that sold, 6 units. And it's amazing the progress we've made in 70 years. Just if you think of the first computers that were used by very few people that could do only one thing, and they had a memory, like today we have memories of, I don't even know how much my smartphone has, megabytes, which is millions of bytes. And back then it would have been 5,000 bytes would have been a lot. So it's amazing the progress we've made. I have this picture because the original programmers were consistently women. And very few people paid tribute to the fact that the machine was built by the man, designed by the man, but the ones who programmed it actually were mostly women. Vast majority were women. Take a break?
Mm-hmm. So do you want to take another trip down to Mountain View for the computer?
Yeah.
Yeah.
So
Yeah, they have
awesome.
some of these machines. Do you have yours?
I did it online. They sent to me.
She said the same thing. So I can throw this away.